topology for the demo I'm about to show you is this. So across the top of the screen, we've got an overlay network spanning across 3 different CenturyLink Cloud locations. And then connected in sort of standalone, we've got a 4th CenturyLink location. And what I've got here is just a really simple to-do list application. It's very straightforward, web server, app server, database kind of app. Originally started life on VirtualBox on my laptop, and we've now kind of gratuitously smeared it across 4 different clouds. So, front end is a web server. I'm kind of showing that to demonstrate IPsec connectivity. So this would normally not be something based in the cloud. This would probably be Cisco ASA or Juniper SSG or something as the endpoint. But we're just using another VNS3 to simulate that. And then the main cloud network, we've got 3 different managers running in 3 different locations and creating a single network across the top there. So let me dive into that, and I'll bring up the application itself, and I'll also show you the various different moving parts. So starting on the right-hand side of my screen, this is just the CenturyLink control panel where you can see I've stood up a manager, and in each case an instance connected into that manager in 4 different locations across the CenturyLink Cloud. The application on the left-hand side is the to-do list, so I could type in hello CenturyLink and just add that onto the to-do list, and you can see that that's all just very straightforward. So I'm going to start off just kind of showing you what's going on with the web server here. So web server is just very basic Nginx proxy, so I've got it listening on port 80, and then it's forwarding all of its traffic on to the application server upstream. So that's 192.168.56.111. Why that IP address? That IP address comes from the VirtualBox default host-only network. And so one of the points here is I've been able to migrate my application and keep the IP address that it first had on my laptop. So I've not had to change that at all. So how does it get from that web server to IP address? Well, it's getting there down an IPsec connection. And here I'll jump into the individual admin consoles as the network managers. So if we're looking at the web end of this, there's a few things that I can show you here. So I've got the web server connected in using a client pack. It's got a different overlay network to the one at the top of the screen. And then I've got my IPsec connection, so that's taking my traffic from that local subnet and to that 192.168.56 remote subnet. And there's one tunnel effectively doing that there. So I jump over to the other side of that. We can see the other end of the IPsec connection, and it's just the corresponding local subnet and remote subnet, and we've got that connected in. So that's allowing my application to connect over IPsec from one location to another. So next up is the app server itself. And here we've got a very basic Ruby Sinatra application. And we've got some coding horrors in here. So we've got hard-coded passwords, we've got hard-coded IP addresses. And the whole point is that because we've got control over addressing, I don't need to worry about the fact that I've got things hard-coded into the application, because I can deal with those outside of the application in the infrastructure, in the overlay networking. There's also a sort of good case of using an overlay IP address here. So we're binding to the overlay IP address, which would mean that that service is invisible on the underlying network. So that's one way that we can control access into things running in the overlay network. So if I take another view of that VM, we can see it being hit there by a load balancer. I'll come to the load balancer in a minute. If I just run some traffic through that, then you can see that happening. And there's a little bit more traffic going through. So one of the things that's worth kind of emphasizing here is that the overlay network is made up out of encrypted connections. We generate the keys for those encrypted connections on the managers. And when we peer managers together, they all share a common key set. So those three managers making up the overlay network of the sort of top of the diagram all share a common key set. So I can see 97B05 at the start of my checksum there. If I go to database manager 97B05, so it's consistent across our app tier, our database tier, and the backup database that I'm going to be migrating over to in a moment. And what I can't do is kind of take a standalone manager like this one here with a different key set. So I could try and go into manager peering and try and peer that up with one of those, and they're not going to peer together because they don't share a key set. So it's impossible for an administrator to sort of fat finger two foreign networks together using the peering mechanism, because everything is actually enforced by the cryptography. So if we look at the database now, if I do a quick update of my database query, you can see that the CenturyLink line was added in there. And what I can do is I can go and drop that out, and we can see that we've got a live database. I'm going to switch this database server over from Salt Lake City to Santa Clara. And so that you can see that I've done it, I'm going to take it over to a database that's got different state in it. So it's just going to say backup DB rather than the list of to-dos that I've got on the left there. And how I'm going to do that is I'm simply going to disconnect one of those servers from the overlay network and connect another one in. So I'll quickly stop my connection at one end. And if I was to go to the manager that was connected into, I'll see straight away I've lost the connected tank. So I've still got the app server connected in there, but I've lost the database server. If I go to the application itself, what I'll see now is if I click on to-dos, it's going to time out because it's not able to reach its database. So let's spin up the backup database by connecting it in. So immediately that's come up, and if I go into its local manager, we see that before when I looked at that screen, I had that database IP 101 connected into manager 1, and if I refresh now, we'll see that that virtual IP is moved to manager 3, which is this manager. And if I go to the manager that's nearest to the application server, we can see that last time we looked at this page, it thought that the database was on manager 1, and we refresh that should have propagated over, and it has already, which means we can see it on manager 3. If I go to the application itself, we saw that it did time out when I had my database shut down. But because the database is reconnected into the overlay network now, when I do a refresh of that, I'm seeing my state as backup database. So I touched upon our containerized functionality on the way through, and there's a few other things that are worth kind of pointing out here. So one is I've got a container doing some SSL termination for me here. So that's got a certificate installed. It's just a hand roll certificate, but it could be any certificate, so it could be a proper certificate from a certificate authority. And I've also got a load balancer configured. There's only one route through the application, but the load balancer is giving its statistics report that we can see there. And if I go into the config of manager, we can see how we've got that container deployed, doing proxying and SSL, and we've got SSH access into it. So I can use that SSH access and show you something like the load balancer config here, and we can see that it's load balancing into that overlay IP for the app server of 111. Something else we can do here with containers is I've got network intrusion detection system set up on the manager running the database. And so what I'll have to do here is actually flip back over to using the original database so the traffic actually goes to the right place. And if I go to my application, that should pretty much straight away get me back to my original to-do list. which will show us that we're on the original database. It's going to take a moment for that to propagate through the managers. So what I'm going to do here is each of the... Let's render quite quickly. I've got my network intrusion detection set up here to look out for MasterCard numbers. And so if I put something that looks like a MasterCard number into my to-do list, that's going to be traveling over the network. That number actually, as we can see here, went over the network a number of times. And the app server was talking to the back-end database, which gives us a bunch of hits in the network intrusion detection sensor. And so what we're doing there with the containers is allowing customers to drop in additional functionality. And because it's very application-centric, things like NIDS rules can be very tailored to specific threats.